Let's take a look at a generic router architecture. As a summary of basic router function, a router receives a packet. It then looks at the packet header to determine the packet's destination. It looks in the forwarding table to determine the appropriate output interface for the packet. It modifies the packet header, such as decrementing the time to live field and updating the IP header checksum appropriately. And finally, it sends the packet to the appropriate output interface. The basic I/O component of a router architecture is the line card, which is the interface by which a router sends and receives data. When a packet arrives, the line card looks at the header to determine the destination, and then it looks in the forwarding table to determine the output interface. It then updates the packet header, and finally sends the packet to the appropriate output interface. Now this drawing shows just a single line card, but in fact, when the packet is sent to the output interface, it must traverse the router's interconnection fabric to be sent to the appropriate output port. So in fact, we can zoom out from that depiction of a single line card, and what we have is a bunch of line cards that are all connected via an interconnection fabric. Each of these line cards has a lookup table, the capability to modify headers, and a queue or buffer for packets as they enter and leave the line card. In other lessons, we talk about several important questions, such as how big queues should be and how lookup works. In the rest of this lesson, I'll discuss important decisions in router design, such as the placement of lookup tables on each line card and the design of the interconnection fabric.